Hi guys, so you see me starting out with this little weird box here. It is called my ray box, and it's literally just a box that gives me some light that you can see. Focus on the bright box lights. I see some strenuous ones here, but just ignore those for right now. And we're talking about curved mirrors today. So I'm going to start with parabolic and concave. Here is a parabolic mirror, which means it would just keep going into space. It won't go into a circle. Straightened out. I have 4 rays of light coming in. Now it's not perfect, but you can see that, for example, this ray hits here and bends, this ray hits here. Every one of these hits this shining mirror, and they come together very close to a single point, and that is called the focus. This is considered concave because you're in the cave, and it is considered also a converging mirror. A slightly different version of this is a round mirror, concave also. It just means that this would make a circle. That's the kind we're going to actually draw and do the most. You can still see again that there's a point right here called the focus. Rays from very far come in parallel and they will cross at that focus. Your satellite dish works like this. Your mirror at the dentist works like this. If I turn it around, again, that's concave and it's called converging because it brings rays of light together. If I turn this around, I have now made it convex. Convex meaning curved outward. And notice that the rays of light, not only are they going away, they're dispersed. They're not as tight. You kind of have a little loose energy loss. If you were to follow them backwards, like to here, and to here, and to here, they would still cross at that focal point. Oh, I know, I have a noisy house. And that is where those reflected rays radiate from. In the parabolic, same idea. It is convex. The rays of light are on the curved outward side. They are reflecting away, and the point they are coming from would be that focus. So if I were to draw that, and you're going to need a ruler, we're going to definitely do some drawing today. Okay, so let's pop to the notes. I'm going to turn the light off, turn this light on. Woo, I know. All right, let me zoom in a little bit. So, nothing to write on this page. This is really, well, we got a little bit. All right, 2 kinds. We have convex, which is you're having light hit that side. Concave, you're going into the curvature. So light would be going this way, light would be going this way. Each one of them has a focus. It's just a different, whether it actually strikes it or comes near it, that kind of thing. So, concave, the rays of light actually pass through the focus. Convex, they reflect as if they came from the focus, but they don't actually touch it. Sorry, I'm putting my stuff away. 2 pictures to kind of show and just remember what you just saw. Okay, so parallel rays of light come in to the concave and they reflect through the focus. Now, we're only going to use spherical mirrors, meaning they're not parabolic. I showed you both. The point that is twice the focus is actually the center of curvature. We will usually not call that the center, even though it is. We'll usually call it twice the focus. And this dotted line that's here, we call this the principal axis. It's kind of an axis of symmetry that we look at. And we look at all the images formed and things of that nature. All right, and here is the convex. Again, here's the dotted line. Every one of those reflected rays appear to come as if they came from that focus. These are not exactly straight. And that F and the 2F fall on the back side. All right, so we're going to do some practice drawings to talk about how these images form. All right, so here is the first one. You need a nice straight edge. A ruler will be fine. There's essentially 2 rays that we draw. The first ray is going to go, and my arrow here is my object, if you will. And these will be our descriptors of real, virtual, all of those. All right, so the first ray is going to go parallel to the curve. Now, when you're doing this, try not to put your ruler under here because you're going to go crooked because you really want to go as parallel to the principal axis as possible. So draw from the top of this, pause me as much as you need. and then it's going to reflect through the focus. So I'm going to aim that now. And I have my focal point's kind of fat here, so I'm just going to do the best. And please use pencil. Make sure you're using pencil. All right, so that's the first ray. The first one, we call it parallel focus. The second ray is the exact opposite. It goes through the focus. And again, I'm going from the top of the arrow, which is my object, through the center of the focus. Make sure you're putting arrows on them so you know which one's going towards the mirror, which one's going away. And again, you're going to draw one that goes parallel. So don't put it up here. You can't get you'll get crooked. Do the best you can to being parallel and draw this straight out. So what we're looking for, we're looking to see, first of all, we don't look at the incident rays. We're only looking at reflected rays. Do they cross? And they do right here. And they cross below the principal axis, which means my image of an arrow is upside down. And draw it in here so you can see it. And that's basically how the rays of light form images for these mirrors. Reflecting telescopes use these mirrors to make images when you're looking into space. All right, so when we describe the image, we're using the size of this and the orientation of it compared to the original. So first of all, you can see that it is smaller. It is definitely smaller than the original. It is upside down. Okay, so we call that inverted. And since the rays of light that reflected actually crossed, it is a real image. Real images are the only kind that you can project and make a picture of, and that's a difficult thing for me to show you on camera. All right, let's do the next one. Notice this one is much closer than the focal length. The other one was a little bit farther away, so it starts the same. Straight edge, try to be parallel to the principal axis. Start at the top. Go straight to the mirror. Try not to go through the mirror. And then reflect it through the focus. I know it's going to go on top of it, but that's okay. And try to hit the center of the focus. Okay, so parallel focus. Now, the next one has to be focused. Since it's not behind like the other one, it's in front. I have to come from behind. I won't actually draw from the focus. I'm just going to line it up. So line it up so that's touching the middle of the focus and the top, and aim. So that's lined up with the focus. So parallel is the next. So I'm going to hit that spot, trying to be parallel. There you go. These two rays will never come together. You will never get a real image. The way we find the image when the two rays will not cross is we extend them backwards with our virtual rays. So dotted line, so each reflected ray only. Mistake people make sometimes is they do the incidence. Oops, mine slid. Make sure you're using your ruler. So this is where the virtual rays crossed, and you'll notice they cross above the principal axis. So my image is going to point up, right side up. All right, so my descriptions, I compared this to the object. So first of all, is it definitely bigger or larger? It's right side up, so we say upright. And if you had to extend the dotted lines, it's a virtual image. You can't project it onto a screen. So those are two examples of concave. Now we're going to do a convex. Similar but different. So same process. Follow me along. All right, so I'm going to use the black line here. So the first ray is going to do, try not to be crooked, parallel to the principal axis. So it's still parallel focus. The problem is it doesn't go through the mirror. It reflects off the mirror as if it came from the focus. So when you do this one, line it up with the center of the focus and where it struck the mirror. And there's your reflection. That's that divergence. Okay, the next one, same idea. We're going to go to the focus. We're going to line up the top of the arrow with the focus, but we're going to stop when it hits the mirror. So right there, it's lined up with the focus, but I stopped at the surface. And then it's going to reflect parallel. And again, make sure you can see this line. Get as parallel as possible. Again, I've got two reflected rays that will in no way ever come together. So I must extend the reflected rays. Make sure you're using a ruler. Dotted lines, dashed, whatever you want to call it. Only reflected rays. Don't worry, yours doesn't come out exactly like mine, but it should be similar. They cross right here. Notice there's no arrows on these. It crosses above the principal axis, so my image is like this. Okay, so let's go size, smaller. It is upright. And again, reflected rays would not cross. I had to do the dotted virtual rays. That means it is a virtual image. Go take a shiny spoon and take a look in it. Go in the concave side. You'll see yourself upside down if you're far away. You'll see yourself right side up if you get in there close. And then turn the spoon over and you'll see yourself as right side up. All right, go back to this if you need to. We're going to do 6 more.